Hi students, welcome back. Today I will be dealing with the most toughest chapter of ICC physics, that is electromagnetism. Let's start with the syllabus. So the syllabus contains all these things, but today I will be dealing with Oersted experiment on magnetic effect of electric current. Let's start with it. What is a compass needle? As you can see in this figure, this is a compass needle and it always points to the north side and it is always marked with red. A compass needle is a small magnet. Its one end which points towards north is called north pole. This one is north pole, and the end which points towards south is called south pole. What is Oersted's experiment? The first evidence of any connection between electricity and magnetism was established by Hans Christian Oersted. He accidentally discovered that as he laid a wire carrying an electric current near a magnetic compass needle, it got deflected as if acted upon by a magnet. See, here is the setup. As we can see that there is a wire connected to a battery and it is a conducting wire and it is a closed circuit. So whenever a battery is connected to a conducting wire and whenever it is closed, we know that electricity flows through it, and whenever electricity is flowing through this wire, and he accidentally observed that a magnetic needle was placed near it, it is getting deflected. So this observation led to the discovery that when current passes through a conducting wire, magnetic field is produced around it. What is magnetic field? The space around a magnet or a current carrying conductor in which either there is a force of attraction or repulsion which can be experienced is called a magnetic field. So how can we see this magnetic field lines? We will do this experiment. This is a very simple experiment and which can be done at your home. So take a bar magnet or a simple magnet and place it on a cardboard. Sprinkle some iron fillings around the magnet. Tap it gently. Then iron fillings, we can see that they arrange themselves in a certain pattern as shown in the figure. So what can we conclude from this? This pattern demonstrates that under the influence of magnetic field, the fillings align themselves along the magnetic field lines. We can see that it is like a curved path and it is being closed at the poles. We will see what does it implies. What is magnetic field lines? These are imaginary lines used to represent a magnetic field. A field line is the path along which a hypothetical free north pole would tend to move. The direction of magnetic field at a point is given by the direction that north pole placed at a point would take. Now do one thing, the same experiment which I had told you previously. Remove all the iron fillings, just keep the bar magnet like that, and what we have to take, that compass needle first we have to put at any point. Here you can put, here you can put, here you can put, any point you can put, and try to see where does the north pole, that red color mark, points. And here if we put, we can see that the north pole is pointing like this. Here if we put, again the north pole will be pointing here. If we put here, north pole will be here. Similarly, by observing at all these points we have observed, the north pole will be pointing like this. And similarly till the end we can see that there is a curved path followed by the magnetic lines. Similarly, we can take another points here and we can see that there are many concentric circles around here. So from that experiment, see, this is the diagram, shows it all clear. Whenever we have put the magnetic compass and observed that the lines are always in concentric circles. What is a concentric circle? having a same center and many circles surrounding it. It looks like right? The center is here and there are many circles surrounding the same center. So what we observe from this experiment about the magnetic field lines. Outside the bar magnet, the magnetic field lines originate from North Pole. We can see that it is like coming from this North Pole and ending at South Pole. So originate from North Pole and ends at South Pole. Inside the bar magnet, the line moves from South Pole of the magnet, South Pole of the magnet towards the North Pole. It is inside the bar magnet. So how can we observe this one? We can put that compass needle over it and see that it is like South Pole. It is inside the magnet, or over it you can see that it is pointing like this direction, south to North Pole. Now magnetic field lines always form closed curves. We can see that it is already closed. It is starting from north and ending at south. So all magnetic field lines formed a closed path. The regions where magnetic field lines are closer, near the magnet they are closer, these field lines. So here they are strong, and here where there are far apart means there is a weak magnetic field. The direction of magnetic field is taken to the direction in which North Pole points, that we already know. The magnetic field lines never cut each other. In case the two field lines intersect each other at a point, then it will mean that at the point of intersection the magnetic needle would point in two different directions, which is not possible. So they never, remember this thing, that they never intersect with each other. So what we studied in these slides, Hans Christian Ørsted experimented and studied that every electric current carrying conductor has a magnetic field surrounding it. Now this right hand thumb rule, let's see what does it state. Right hand thumb rule gives the direction of magnetic field in a straight conductor by this right hand grip rule. So what we can see, if we hold the current carrying conductor in your right hand with the thumb pointing along the direction of the current, then the direction in which the finger curl gives the direction of the field. See here, thumb shows the direction of current, then the direction of magnetic field is given by the finger curls. This is an important rule, right hand thumb rule, which you have to by heart it. If you liked my video, please give a like to my video.